This one's trickier, and you're going to say, well, why? Because if I were to go to the center term, that's this guy, and I were to square this is just not going to be 2 to the x. So I need to do something. And here's the trick. By the way, you don't come up with these necessarily on your own. What happens is, somewhere along the line, you run into a problem, and you either run into a class where the problem is done and you're shown the trick, so that when you run into it again, you know such a trick exists, right? Or you look it up in a book and you see that such a trick exists because you see how the problems work. But 2 to the x plus 2, I needed a 2 to the x. Well, that's easy enough to get. Property of exponent says this is 2 to the x times 2 to the 2. Because if the bases are the same, you add the exponents. So I'm going backwards on the property of exponents. That means this guy is really 4 times 2 to the x. He has a coefficient of 4. 2 squared is 4. That's where this came from. And then you have 2 to the x. That's what 2 to the x plus 2 actually is. So I need to rewrite my problem. And he gets rewritten as 2 to the 2x plus 4 times 2 to the x minus 12 equals 0. Now when you look at it, here's the variable portion of the middle term, and when you square it, you then get 2 to the 2x. So b is going to be 2 to the x. Then I'm going to square both sides. Property of exponents would say this is 2 to the 2x. That says wherever you have a 2 to the 2x, you put b squared plus 4. Wherever you have 2 to the x, you're going to put a b. Minus 2 minus 12 equals 0. Now you've got a problem that you can do. It factors. And it's going to be 2 and 6, and plus and minus. So this says that b equals 2, b equals negative 6. Then I go back up. What was b? b was 2 to the x. So 2 to the x equals 2. 2 to the x equals negative 6. Again, 2 to the x is never negative 6 because an exponential is never negative. And 2 to the x is equal to 2 to the 1. What's x? If 2 to the x equals 2 to the 1, what's x? Yeah, x equals 1. Because if the bases are the same, then the exponents must be equal. Now this guy is particularly interesting. Why? Because if I square the square root of the natural log of x squared is equal to what? Natural log of x, so it's equal to the guy in front. So b is equal to the square root of the natural log of x. Now again, I square both sides. So if I square a square root, it removes the radical. So b squared is just the natural log of x. And now you've got your substitution. The natural log of x is b squared minus, the coefficient is 3, square root of the natural log of x is b, plus 2 equals 0. And this factors b, 2, 1, both minus, so that b is 2, b is 1, and now I go back. If b is 2, b is the square root of the natural log of x. That's equal to 2. b is the square root of the natural log of x. That's equal to 1. Now what do I need to do? Square both sides. I've got to get rid of the radical. So the natural log of x is 4. Now what? I need x. Well, I've got to rewrite this guy. What base is natural log?
X equals e to the 4.
Yeah. What is the base of the natural log? E. So this is log base e of x is equal to 4, or e to the 4 is equal to x. Same thing with the next one, square both sides, so that the natural log of x is equal to 1. Natural log is log base e of x is equal to 1. And then rewrite it in exponential notation. E to the 1 is equal to x. So x equals e and x equals e to the 4th. And that both of them will work. They're both nicely positive numbers. Not going to cause any problems with the arguments.